No problem.
Installing Ignition on a Windows operating system is pretty straightforward. You just need to download the installer file from the downloads page of our website, inductiveautomation.com, and then run that file. I already have the downloaded installer executable here, so I'm just going to double click on it to run, and then the installer process is going to begin. We're greeted with the Ignition installer. Clicking the next button allows us to walk through the installation process. This section allows us to specify installation directory, as well as a gateway service name. I'm going to leave these settings for defaults and then click next. We can then choose if we want to do a typical installation or a custom installation. A custom installation is going to allow us to choose which modules we want to install, while a typical installation will install a standard set of the most common modules. Note that the modules you install could be subject to licensing or edition constraints, so if you're planning on installing Ignition Edge or Maker editions, there's not much point in installing modules that aren't supported. That said, I'll stick with the typical option and then click next. Now that we've made all of our selections, we're ready to begin the installation, so I can click the install button and we'll get the install process started. You'll notice the installation process is very quick. It'll usually take less than 3 minutes. Additionally, you may have noticed that we didn't have to install Java first before we ran the installer. As of Ignition 8, Java comes prepackaged with the Ignition installation, so we don't need to install or manage it separately. So we can see that the installer has finished running and we're ready to start the Ignition service. So I'm going to click on the finish button, which will go ahead and start Ignition. Now when you install Ignition 8 for the first time, your web browser is going to open up to a page like this. This welcome page takes us through a process known as commissioning. Commissioning allows us to set up our gateway for the first time, including selecting which edition we'd like to use, and setting up ports and login info for our gateway. First, we have to select which Ignition edition we'd like to use on our gateway, so we can choose between the standard Ignition platform, Ignition Maker edition, or Ignition Edge. I'll just go ahead and select Ignition. Next, we have the end user license agreement. You can go ahead and read through that, and when you've done that, you click on the radio button next to I have read and agree with the terms and conditions, then click the next button to proceed. This next page allows us to create our first user account, which will be used for logging into the gateway webpage and Designer, at least initially. So maybe I'll give my user a username of Ignition. Next, we need to provide a password, so we recommend entering in a strong password since these credentials are used for access to the gateway's most sensitive areas. The password strength meter on the right lets me know that I've typed in a strong password, so I'm going to go ahead and click on the blue next icon down at the bottom right. This last page allows us to configure which ports the Ignition gateway should run on. The default HTTP port is 8088, and the default HTTPS port is 8043, but we can change them here if we wanted to. I'm going to leave those at defaults and click on the blue Finish Setup button in the bottom right-hand corner. Now that we've finished setting up things for the first time, we're ready to click the Start Gateway button. So I'm going to go ahead and click on that, and the Ignition Gateway service is going to finish starting up. One useful note, the user profile and port settings we configured can always be changed at a later time. In later videos, we'll take a look at how we can make those changes. When the Ignition service finishes starting up, we're greeted with the Gateway homepage, where we're ready to navigate over to the Config tab and start setting up connections, or open up our Designer and start building our application.
In this lesson, we'll look at upgrading Ignition. I have Ignition installed here on my local system, and I would like to upgrade to a newer version. Before we do anything with the upgrade process, we generally recommend you go to the config section of your gateway, go to backup/restore, and take a gateway backup with a big blue button here. If you're unfamiliar with what that is, that's basically a copy of your entire gateway, all your projects, all your configurations, saved into one file. The upgrade process for a gateway is incredibly simplistic, and it's rarely error-prone at all, but it's always a good idea to just take a gateway backup just in case something does go awry. Okay, so now that I have a copy of my system here, the next thing we need to do is we need to figure out our licensing situation. So if you have a license applied, you want to make sure that your license allows for upgrades. So if you purchase a license for Edge or Standard Ignition, then you may want to reach out to your account rep to make sure your license is capable of upgrading, which is only ever an issue on major and platform version upgrades. So say you're upgrading from Ignition 7.9 to Ignition 8.1. Now this generally isn't the case if you're upgrading minor versions. So if I go to the status section here, and on the overview page here, you can see that I'm currently running 8.0.13, and I'm going to upgrade to 8.0.14. So it's only the last number that changes there. That's a minor upgrade. It generally doesn't have any sort of licensing restrictions. Now if you're trying to upgrade a Maker Edition gateway, then no worries at all, since you can easily generate a new license if you even need to. Alright, so we've got the licensing stuff out of the way. I'm going to switch tabs here, and on our main website, specifically to go to our downloads page, which may or may not look different depending on when you view this video, I'm going to scroll on down here, and I'm going to add the installers for 8.0.14, which again is the version I'm trying to upgrade to. You do have some options depending on your various operating systems here. Now I'm going to show you how to use the installer to upgrade, since that's really the easiest and generally the preferable approach, but we do have a generic zip, which you can use to upgrade if you prefer. If you're going to take the zip route, there is a readme file that's in there that will tell you what to do, so I recommend you follow the steps inside of there. Now we do have right now these Edge zip files here. These were sort of a dedicated way to install Edge, but the generic zip, as well as the installer, I'm going to show you here, can all upgrade Edge, Maker, and Standard Edition gateway. So you don't necessarily need this last option here if you're going to go the zip route. You can take the generic zip. Alright, so I'll save the trouble of watching me download this. If I head over to my desktop, I do have an installer ready to go. Now, upgrading with the installer is more or less the same process as just installing Ignition with the installer. So really, you just need to be able to run it. So I'm going to show you how to do this on Windows, but once you get to the point where you're running the installer, the process basically becomes the same for all the operating systems. The only thing I will say about different operating systems is that on Linux, make sure the installer can run as a program. So there's some permissions you have to change on the file to get that to run. For more information, take a look at the installing on Linux lesson, or take a look at the installing content in the user manual. But I don't need to do that right now, so I'm going to go ahead and right-click, and I will run this installer here as an administrator. Now let me move the install wizard over into view. This one starts off as the same path as just installing on the fresh system. I'll hit next here, and my current Ignition installation is installed as path here. So when I try to go to the next step, the install wizard is going to detect that Ignition's installed there, and it's going to say, oh hey, do you want to upgrade instead? Which I do, so I'm going to press the yes button here. and it's going to switch over to the module selection area. And this more or less looks like what the custom installation type looks like. The one thing I do want to call out is the additional modules tab here. Now, our installers, and this is true for the zip files as well, have some of our modules, but they don't have any third-party modules inside them. So when you're upgrading, the installers will try to upgrade your modules, but there will be some cases where the installer doesn't have some of the third-party modules you downloaded. So at this point, it's basically asking you what do you want to do. So I have an MQTT recorder module on my gateway here, which isn't included in our wizard. So by default, it does set it to keep as is, which basically means don't touch that module, finish the upgrade process, and then I'll upgrade the module later. If I had the forethought to download a newer version of that module, I could select upgrade here and simply pass in the MODL file. Or I could remove it if I didn't want it anymore. I'm going to leave this as keep as is.
Давай, думаю.
There may come a time when you want to add a new module to your Ignition gateway to get some new feature that you didn't have before, or even update a module that you already have within your gateway to get the latest fix from a newer module. Both of these things are really easy to do within the Ignition gateway webpage. First, we need to open up a web browser and come to our gateway webpage at localhost:8088. We then need to go to the configure section and log in with your username and password. Once here in the configure section, we're then going to go to the modules page on the left-hand side underneath the system section. Here, we get a list of all of the modules that we have currently installed within our gateway. Currently, there is a module that I don't have that I would like to add, and that's the alarm notification module. To add a new module, I simply need to scroll down to the bottom of this page and click on the Install or Upgrade a Module link at the bottom left. On this next page, we need to click on the Choose File button in the upper left-hand corner and choose the file for the module that we want to install. I've already downloaded a couple of module files from our website for us to experiment with. You'll notice that these module files have a special extension, .modl, which stands for module. I'm going to select this module, and then click on the Open button in the lower right-hand corner, and then the Install button. You may be taken to a page like this, where you need to accept a new software module license agreement, if there's a new version of it in this module. We simply need to click on the checkbox, I accept the terms in the license agreement, in the lower left-hand corner, and then click on the Accept License button just below that. The module might also have a new certificate. If it does, you will be taken to a page that looks like this, where you need to add the module certificate to your list of trusted certificates. To do so, simply click on the checkbox next to I want to add this certificate to my trusted certificates, and then click on the Add Certificate and Install Module button. As you can see, I now have a new module in my module list, the Alarm Notification module. Now the version of the module that we just installed is version 5.0.0 Beta 0. I just so happen to have a newer version of the module, so let's take a look at what the upgrade process is for individual modules as well. It actually works in much the same way that we installed the original module. I simply scroll down to the bottom of the page and click on the Install or Upgrade a Module link. Again, I need to click on the Choose File button and select the module file that I want to install. In this case, I'm going to select my newer Alarm Notification module, and then click on the Install button. You'll notice this time, I didn't have to accept a license agreement or add a certificate to my list of trusted certificates. This is because the new module used...
Чего не можешь? Я не можу цикнути. Не нажимаю цю кнопку. А, курс прогресс 100%. О как. Overview. Так я... Шайця не то проходив вже. О. Ок. Ага. Ура.
Ignition redundancy supports a two-node system, meaning there are two copies of the gateway running. One is designated as the master gateway and the other is the backup. If we review the architecture setup on my gateway, here in the status overview screen, you'll notice I already have redundancy set up. My master gateway named Alpha is hosted locally, and my connected backup gateway is hosted on another computer. Both systems are identical. This is because when changes are made on the master, they are queued up to be sent to the backup node. When the backup connects, it retrieves these updates or downloads a full system backup if it is too far out of date. The master node is responsible for all system configurations. The backup node will not allow you to edit properties. If the master system were to fail or the computer were to shut down, the system will automatically fail over to the backup system and continue running there. All clients that are currently running will automatically switch over to the backup when a failover occurs. And there are many redundancy settings that you can alter that affect how a failover occurs and what happens to the system when the master comes back up. One important thing to note about redundancy is that the gateways don't have to be installed on the same type of system, meaning we could have one gateway via 64-bit and another one via 32-bit, or we can have our master via Windows machine and the backup a Linux machine, although it is recommended to keep the operating systems the same. The only thing that needs to happen for redundancy is that the gateways need to be the same Ignition version.
In this lesson, we'll take a look at configuring redundancy across two different gateways. In my web browser here, I have two tabs with a separate gateway in each tab. I have beta, which is going to be the backup of the redundant pair, and I have alpha, which is going to be the master. Now, redundancy requires that I make some configuration changes on both gateways here. The order you do this in doesn't matter too much, but for the purposes of this example, I'm going to start with the alpha gateway, or the master gateway. So on alpha here, I'll head over to the config section, and under the system header, I'll click on redundancy. The property that's ultimately responsible for whether or not a gateway is participating in redundancy is this mode property over here. By default, all Ignition gateways, when they're installed, are set with a mode of independent, which means they're not participating in redundancy at all. So alpha here needs to be set with a mode of master to make it a master in a redundant pair. So I'll click on the dropdown and select master. I'll scroll down a little bit more on this page, and I did want to point out that there are master node settings and backup node settings. So these settings are only applied to this gateway depending on the mode of the gateway. So because I'm going to set alpha as a master, the master node settings will be applied to it. The backup node settings would only be applied if this gateway was set to be a backup. But I'm actually not going to make any other changes. I'm just going to scroll down and click save changes, and then I'll click confirm. And that's actually all I have to do to set up redundancy on the master gateway. It's pretty straightforward. Let's switch over to beta. I'll go to the config section on beta. Again, I'll go to the redundancy page. And I need to tell this gateway that it should be a backup, so I'll change the mode to backup. Now, in a redundant pair, the backup gateway is the one that's responsible for reaching out to the master. So I need to tell my backup gateway here where the master is located.
É DJ moleque bom, ele tem experiência, esculacha a concorrência, tem moleque vai, vai, é DJ que vai, é DJ que vai.
You may recognize this port if you've looked through our documentation, but the 8060 port is the primary port our gateway network feature uses. So the redundant pair will utilize the gateway network to communicate with each other, which is actually going to come up in just a moment. Now, I don't need to make any other changes here. We can scroll on down, and I'll click Save Changes. Now, before I click Confirm here, now would be a good time to back up any work that's on this gateway that's going to become a backup. When synchronization occurs, this backup gateway here is going to lose all of its unique configurations. So if you've been building any projects or anything that you wanted to save, you would want to take either a project export or go ahead and just take an entire gateway backup if there are tags or other gateway level configurations you wanted to save and maybe import into another gateway elsewhere. Now, I don't have to worry about that, so I'll just click Confirm, and changing a gateway to a backup does require a little bit of time, so I'll just speed this part up here. Alright, so now this gateway is set to be a backup. Now, how can we verify that this gateway is now a backup? Well, we can head over to status here, and on the overview page, once this page finishes loading its information, we can see that this gateway does have a peer. So if we look at those little boxes there, we can see that this is set as a backup, and it's supposed to have a master, but it can't find the master. For some reason, there's a communication problem. You probably also noticed that there's a gateway network connection problem down below. Well, that's because the two gateways can't talk on the gateway network. So this is a problem you might run into, naturally, but with any sort of gateway network connection, out of the box, you need to approve connections across different gateways. So when you're setting up redundancy, the backup gateway will make an implicit outgoing connection to the master gateway. So I just need to switch over to alpha here, and under config, I will go to gateway network settings. I'll click on incoming connections, and we can see there is in fact a remote connection that's not approved. So I'll just go ahead and approve this because I do recognize this connection. I'll confirm this, and there we go. So now it's approved. We can switch over to status here on alpha, and if we give it just a moment, and there we are. We now have our redundancy set up. Now, I'm looking at this page on alpha, or the master, but you'll see a similar page on the backup. Now, if I click on the peer box here, it does take us to the status section, the redundancy page, which has information about the redundant state. Now, you'll notice the peer is no longer connected. That's because the backup initiated a gateway restore. It's restarting itself right now so that it can inherit all of the configurations from the master, which has to happen initially just so the In an earlier lesson, I showed you how to configure redundancy across two different gateways, but I didn't talk about licensing. Now, redundancy is actually a platform-level feature. It's not owned by one module, rather other modules utilize it. However, in a production environment, you're going to want a license on both the master as well as the backup, so you will need two licenses. The main reason for that is when a failover occurs, things switch over to the backup. If the backup doesn't have a license and the trial is expired, then none of the modules will run, which more or less invalidates the point of having redundancy in the first place. Now, when you're purchasing a license from us, you do have the option to add on a redundant license, so it's basically a copy of the license you're purchasing, but it's intended for the backup gateway. I'm looking at my backup gateway here, which does have a license applied. If I look at the effective license, there's this backup true item that's being applied. Now, in most cases, you don't really need to know what these details are, what they mean, but the backup one is kind of special in that it sort of marks this gateway as backup only. So this gateway here can only ever be set to a backup mode in redundancy. So if I go to under the config section,
The Gateway Network is a part of the Ignition platform that allows 2 or more gateways to connect with one another and share data. By connecting gateways in the Gateway Network, it unlocks the ability to use Ignition's distributed services, which can benefit systems that have multiple gateways spread out across their facility. Currently, there are 4 major systems that use the Gateway Network. And then there are security zones in server security, which helps to lock down each gateway in the Gateway Network and to keep them secure. First, we have remote tags, which are stored and executed on one gateway, but can be shared amongst any other gateways on the Gateway Network by setting up a remote tag provider on those remote gateways. Similarly, we have remote history providers, which allows you to store and query history data from any gateway in the Gateway Network. Next, we have remote alarms, which allows you to set up alarms remotely and utilize the alarm pipelines of any gateway in the Gateway Network, meaning you can set up alarms on tags in remote gateways, but have them use an alarm notification pipeline that is on a centrally located gateway. So then all of your alarm notifications happen in one central location. Finally, one of the last major services to utilize the Gateway Network is the Enterprise Administration Module. The Enterprise Administration Module allows you to control and maintain multiple gateways from one central gateway called the controller, all connected through the Gateway Network.
In this lesson, I'll demonstrate how to create a gateway network connection between 2 gateways. Setting this up is easy and simply requires 2 Ignition gateways on the same network. If I take a look at my web browser, I have 2 tabs open, one for my local gateway and the other for my remote gateway. I'll start on my local gateway by navigating to Config, Networking, and Gateway Network. This will open up the general settings page for the gateway network, which is where I can configure the basic rules for the system, including the security rules. For example, I can configure whether or not connections are required to use SSL. By default, this will be true, and that means that any incoming connections to this gateway that don't use SSL won't be allowed. If I scroll down, there's also the Allow Incoming Connection setting, which determines the allowed direction of connections for this gateway. This also defaults to true, which means that this gateway will allow connections from other gateways. There's also the Connection Policy setting below it, which potentially further restricts which connections are allowed. By default, this only allows approved connections, which means that any incoming connections from other gateways need to be approved from the Incoming Connections tab before they're allowed. If I scroll down some more, I can configure the ping settings for any potential incoming connections. Each of these settings will have a short description that goes along with it, but I'll link to our user manual page with additional information, including any changes to these settings that have occurred for the various 8.1 versions. Now that I've gone over the general settings, I'll create the actual connection. I'll do that by scrolling up and clicking the Outgoing Connections tab. Then I can click Create New Connection to connect to the remote gateway. Keep in mind with the default settings, incoming and outgoing connections are allowed, so I could have also chosen to create a connection from the remote gateway, and there'd be no difference in the end result. Since I'm connecting to the remote gateway, I'll enter its host name here, but I can also provide the IP address. Next is the port number. For SSL connections, this is going to use the default port of 8060, but any non-SSL connections would use the default port of 8088. By default, the Use SSL setting will be set to true, which is good. If I accidentally unchecked this, my connection wouldn't work because of the Require SSL setting that is still set to the default of true on my remote gateway. I'm going to leave the rest of the settings at their default values for this connection, but I could configure things like the rate that the remote gateway is pinged at, and the timeouts for WebSocket and HTTP connections. Since I'm not going to change anything else, I'll click Create. I'll see the connection show up here, but it'll say it's faulted because I'm not done yet. If you remember in the general settings, by default, only approved connections are allowed. So I need to head over to my remote gateway's gateway network page and go to the Incoming Connections tab and approve the connection. First, since I'm using SSL, I'll need to approve the certificate. And once that's approved, I'll approve the connection by clicking More, and then Approve. The status will then change to running, and if I switch back to my local gateway webpage, that will also say running, and now I have an active gateway network connection between my 2 gateways.
Sure.
A remote tag provider uses the gateway network to grab a tag provider from another gateway on the gateway network, allowing you to share tags between network gateways. If we set up a remote tag provider on gateway A, it will create a link to the specified tag provider on gateway B, and then be allowed to read and write to the tags that exist on gateway B. However, gateway B will still handle things like writing to a PLC, alarms, and history for those tags. A remote tag provider allows tags to be shared between gateways without the need for additional OPC connections for a more streamlined flow of data. Before we get started, you'll first need to ensure that you have 2 separate gateways. In addition, you'll need to make sure both of these gateways are connected through the gateway network. You can see that I have one gateway installed locally and one installed on a remote machine here. Since we have our prerequisites set up, we'll go to the Configure section of the local gateway. Scroll down and go to Tags and Real-Time here on the left. If you already have some tag providers set up here, don't worry about it. Click the Create New Real-Time Tag Provider link down below. Select the Remote Tag Provider option and go to the next page. Here we can see our remote gateway listed. If there were more gateways in our gateway network, they would also appear here. But since we only have the one, I'm going to make sure it's selected and hit the Next button. This presents us with a list of the tag providers on that remote gateway. You'll notice that I only have the tag provider called Default and the tag provider called System. The System provider includes all of the gateway's built-in system tags. Since the default tag provider holds the tags I'm trying to access, I'm going to choose Default as my tag provider and click the Next button. This last page is where we can customize exactly how this tag provider works. Since my remote gateway's name is Remote Gateway and the tag provider is Default, it combined those elements to create this new name. If you'd prefer to use something different, you can change that to a custom name. And here, you can see the gateway and provider sections got filled in automatically, based on my choices from before. These are also customizable, if you'd like to use something else. Here in the History Settings section, we can choose how we want to handle history that may already be set up on some of the tags. In this simple example, there are 2 gateways on the same network, and the tags we want to access from Gateway A, our local gateway, actually live on Gateway B, our remote gateway. If we set up a remote tag provider on Gateway A, it will request the tag information from Gateway B. B will query the records from its database, process the records, then send the results back over to the requesting gateway. Normally, tag history queries are sent through the gateway network, but I can also choose to send them directly to the database if I have a connection to the database on my local machine that the remote gateway is using. This graphic shows the flow of information directly from the database to the querying gateway if database is selected instead of gateway network. When set to database, history requests will run against the database directly. In this scenario, the requesting gateway then processes the data. If the local gateway is connected to the database, then you can use these settings down here to identify that database connection after setting the history access mode to database. Since we're not using the database for this demonstration, I'll keep the drop-down set to gateway network. I can also choose how alarms are going to be handled with these tags. Alarms can either be queried through the gateway network when necessary, or they can be directly subscribed to, which will usually be faster, but it will use more memory than queried mode. If you click on the Advanced Properties checkbox, it will reveal some new properties that I'd like to draw attention to for just a moment. In version 8.1.34 of Ignition, the Enable Tag Reference Tracker Store option was added. This enables the storing of tag reference entries to a database on the local gateway for analysis in a designer. Its default value is true. In version 8.1.4, Allow Backfill Data became another new option. This is set to false by default so that each value is processed fully as it arrives. But if this is enabled, data will be allowed to arrive out of order from the source. Data from the past will be stored to history, but will not be used for alarms, scripts, or subscriptions. Once we have all of our options set, we can go ahead and click Create New Real-Time Tag Provider. You can see that it has now created our new remote provider. Let's take a look at those tags in the designer. I already have a pair of designers open, one for my local gateway and one for my remote gateway. The first thing we need to do is make sure that read-write mode is enabled for both. On the remote gateway, we can take a look at the tag provider called Default to see what kind of tags we would expect in the remote provider that we just set up on our local gateway. My local gateway doesn't have any native tags for the purposes of this demonstration. In the local gateway's designer, we can use this drop-down to select our remote tag provider. It has the same tags as a tag provider called Default in the remote gateway. If the value of this tag were to change in the remote gateway, you'll notice that it also updates on the remote tag provider on the local gateway. When you try to change a tag from the remote tag provider on the local gateway, though, you get an error message and it says access denied. This is because of the way I have my service security and security zone set up. Right now, this connection is read-only. To learn more about service security, please watch our security zones and service security video. You'll find a link in the resources below. Once I've set up security properly to allow read-write access, I can close this error and enter a new value into the tag on the remote tag provider in my local gateway. It also updates in the actual tag provider on my remote gateway. While it may look like the tags are storing history here, the tags are actually on the remote gateway and storing history using the remote gateway's history providers. The tags are going to be stored and executed from the remote gateway, where the tags actually live and originate. If I create or delete a tag on this remote tag provider in my local gateway, that tag will actually be created or deleted on the provider that they originate from on the remote gateway.
A remote history provider allows us to use the history provider of another gateway as well as its corresponding database connection. While it's fairly simple to set up, we first need to make sure that we have at least 2 gateways. I have this one here named controller, which is installed locally, and one installed remotely on another machine. Additionally, we need to ensure that both of them are connected to each other through the gateway network. We then can scroll down on our configure section to the history page under the tag section. As you can see, I currently have one historical tag provider defined. This is because historical tag providers are automatically added whenever we set up a new database connection. This tells us I have a MariaDB connected to this gateway. Let's imagine I didn't have a database connection configured on this gateway. I do have a database connection on my remote gateway, and we can use that one. Because we are making a remote history provider, we don't need to connect this local gateway directly to the database and add another connection to it. We can click the Create New Historical Tag Provider link to get started. First, we
profile.
Scheiße.
In this lesson, I'll demonstrate how to create a device connection using the legacy Allen Bradley Compact Logics driver. This driver is used to connect to Allen Bradley Compact Logics PLCs up to firmware version 20.18. Allen Bradley devices above this version can be connected to using the Allen Bradley Logics driver, which we have a separate video on. To get started, I'll navigate to my Gateway's config page, scroll down to the OPC UA section, and click Device Connections. Then I'll click Create New Device. I'm going to select the Allen Bradley Compact Logics legacy driver since my device is below firmware version 20.18, which is listed here. Then I'll click Next. First, I'll give my connection a name, so I'll name it Legacy Compact Logics. Then I need to enter the IP address of this device, which I'll enter into the hostname field here. I could create my connection now, but I'll call out a couple more connection properties here that might be relevant for you. Below the hostname is the local address property, and this is the local address that we use when establishing a TCP connection. This gives an opportunity to specify an address, but leaving it blank lets the driver just pick an available address. Next, the connection path is a set of 4 numbers that represents a route to the device's processor. In this lesson, I'll demonstrate how to connect to an Allen Bradley ControlLogix PLC through another ControlLogix gateway using ENBT. This is important when you have PLCs on 2 different subnets, and Ignition is only on one of those subnets. By chaining the PLCs together, Ignition will be able to talk to both PLCs at the same time. Before getting started, I'd like to walk through a diagram of an example setup. From Ignition, this routes into the first ControlLogix PLC through an ENBT module. Then it goes out a separate ENBT module, and into a second ControlLogix PLC, and then goes to its processor. We can tell Ignition how to navigate this with a connection path. Connection paths will be unique to a setup, so let's look at a table that describes how to build one, and run through each part in the example. The first number in the connection path is always going to be a 1, and that means to move to the backplane of the first device. The second number is going to be the slot number of the module that we want to move to. This example has another ENBT module in slot number 3, so the second number in the connection path is a 3. The third number is the exit port or the channel of that module. In this case, the Ethernet port is port 2. The fourth number is going to depend on the module we're connecting to in the target PLC. This will either be a controlnet address, a DH plus station number, or in the case of this lesson, an IP address of an ENBT module. The IP address here is 192.168.0.56. The fifth number is going to be 1 again to move to the backplane of the second device. And finally, the sixth number is going to be the processor number or the slot number of the module to move to. In this example, we want to connect to the processor in slot 0. Now that we've walked through building a connection path, I'll show you what it actually looks like to do this in Ignition. I'll start in the config section of my gateway webpage, and I'll scroll down to OPC UA and click on device connections and create a new connection. The PLC that I want to connect to is a ControlLogix on a firmware version greater than 21, so I'll choose the Logix driver. I'll need to give the connection a name, so I'll just call mine ControlLogix ENBT. Next, I need to specify the hostname or IP address of the ControlLogix gateway, so if we look back at that example diagram, this would be the first PLC. Then I'm going to scroll all the way down to the connection path property. My path is going to look a little different than the example we looked at earlier, but it's built in the exact same way. My first number is going to be a 1 to move to the backplane of my gateway. Then my ENBT module is in slot number 2. The Ethernet exit port is port 2. Then the fourth number is the IP address of the ENBT module for the second device, which in my
Let's connect to a device with one of Ignition's Modbus drivers. From the homepage of your gateway, go to the Configure section. Scroll down to the OPC UA section and select Device Connections. Here, you can see I don't have any devices configured yet. Let's begin by clicking the Create New Device link. The next page will contain a list of all your installed drivers. Scroll down to the Modbus section, and you'll see that there are several options available. In most scenarios, you'll probably be using the Modbus TCP driver here. However, if you know you're working with an RTU that connects to a device via Modbus RTU over serial, the Modbus RTU driver is what you should select. If you're working with Modbus RTU that implements the Modbus protocol over TCP, choose Modbus RTU over TCP. If you're uncertain about what to use, check the device's documentation to determine what protocols it supports. The different RTU drivers will only connect with RTU configurations that match their requirements. I know I'm not working with an RTU over serial or an RTU over TCP, so I'll select the Modbus TCP driver. Now, let's scroll down to the bottom of this list and click the Next button. We need to give the device connection a name, so I'm going to call this Modbus. Under Connectivity, we need to specify a hostname. For this demonstration, I'm working with a local Modbus simulator, and I have that local IP saved on my clipboard already, so I'm just going to paste that in. You'll want to put in the hostname or IP of the Modbus device that you want to connect to. Next, I'd like to highlight a few specific properties. First, the